Hey everyone, Mr. Newman here. We're going to focus more on graphing piecewise functions. I'm going to give you steps for graphing them because it gets tricky, especially when you get close to the edge points. And so we'll talk about what I mean by that in a moment. So first off, you're going to identify the x value at the edge of the domain. The edge is where the x is compared on the right side of our function. So you see right over here where it says x is less than 3, and then it also says x is greater than or equal to 3. That means 3 is the edge of the two functions. It's where they're connected, or rather, it's where one stops and the other one starts. So because of that, we need to figure out what is 3 as an input to both functions, even though we only plug it into one of the two parts of the function. When you're actually identifying the function and evaluating the function, we need to graph both of them, and we'll graph a closed circle for one of them and an open circle for the other. So how do you evaluate both of them? Well, you plug that x value into both functions. So we'll plug 3 into the top here, and then 2x minus 1, and we get 6 minus 1, which is 5. So the point that's associated with that is 3, 5, because 3 is our x value and 5 is the output. But this is going to be graphed as an open circle because of this right here. Remember that it is not included, 3 is not included when you have the inequality x is less than 3. So because of that, we need to graph an open circle. So 3, 5, and I'm going to draw a little open circle there to remind myself it needs to be an open circle. Then we plot the point, 3, 5, and it's an open circle right there. Then let's plug 3 into the other function, negative x plus 4, and when you do that, you get 1, and that's going to be a closed circle because of this right here, x is greater than or equal to 3. And remember, a closed circle just means include that point. So 3, 1, and we have a closed circle there. And I'm going to plot the point 3, 1, and make that a closed circle. Now, before we go much further, I have to ask, is this a function? In other words, does it pass the vertical line test? The answer is yes, because only one of those 2 points is filled in. The other one is open or empty. That means that we still have a function. All right. Next thing, let me remind you of this so you can write this down in your notes. An open circle is drawn whenever you have greater than or less than, and that means the point is not included. A closed circle is when you have greater than or equal to or less than or equal to. So now that we have our point, 3 is the input, 1 is the output. I chose that because that is the one that has the closed circle. What I want to do is I want to graph points on either side of it, and I would recommend at least 2 on either side. So for 3 here, I'm going to graph 1 and 2 is less than 3, and 4 and 5 are the numbers that are greater than 3. That means we're going to plug 1 into the function. Now remember how this works. When we plug 1 in, we need to look, is 1 less than 3, or is 1 greater than or equal to 3? Well, 1 is less than 3. That means we're going to be using this function right here when we're evaluating 1. So you plug 1 into the function and you get 2 times 1 minus 1, which is 1. So the point is 1, 1, which I'll make a point right there. Then to evaluate 2, is 2 less than 3, or is 2 greater than or equal to 3? Well, since 2 is less than 3, that means we're going to use 2x minus 1. And we plug that number in, and we notice that we get 3. So the point is 2, 3. Notice that both of those and the open circle all use the function 2x minus 1. So I want to connect those dots. And I'm going to connect that and keep the line going. Even though I didn't evaluate the other points, I know it makes a straight line. And so we draw our graph like that. Now let's evaluate 4 and 5. So to evaluate 4, we need to ask, all right, is 4 less than 3? Or is 4 greater than or equal to 3? And since 4 is greater than or equal to 3, we're going to use this function, negative x plus 4. Negative 4 plus 4 is 0, so the point is 4, 0, which I'll plot right there. Again, we want to check 5. Is 5 less than 3? Or is 5 greater than or equal to 3? 5 is greater than or equal to 3, so we're going to again use negative x plus 4. And when you do that, you get negative 1. So the point is 5, negative 1. Notice that these 3 points all use negative x plus 4 as the function. So I'm going to connect those, and that makes a straight line right there. That is how you graph a piecewise function. Notice that the graph is a function because it passes the vertical line test, and even though it is not continuous, that means it's not connected there in the middle, it makes a jump, the function does have a y value for every x value. Let's try the next one. So first I'm going to evaluate the edge points. My edge point is negative 1 when that's negative 1 is x, so I'm going to plug negative 1 into both functions. When I plug it into the top function, because that's less than or equal to, that point is going to be a closed circle. So the point negative 1, 2 is a closed circle. The other one, when I plug in negative 1 into the other function, because that's greater than, this is going to be my open circle. So negative 1, 1 is my open circle, and that point is not included in the function. Now let's plot those 2 points. Notice these will always be directly above each other because we're plugging in the same x value. And now if you plug in negative 1 for x, we know we get 2 because that's the one that's evaluated. And the points I pick on either side are negative 3 and negative 2, and then 0 and 1. Notice real quick, when plugging in negative 3, I chose this right here because negative 3 is less than or equal to negative 1, so I'm going to use the top function. And when I can do that, I get negative 4. So I plot the point negative 3, negative 4. Again, negative 2 is less than or equal to negative 1, so I'm going to use the top function again. And we get negative 2, negative 1. Notice that all 3 of those purple points are part of the same function, so I'm going to connect them and draw a line on an arrow to the left. For the next one, 0 is greater than negative 1, so I'm going to use this function, x, this part of the function, x plus 2. So 0 plus 2 equals 2, so 0, 2 is a point I'll plot. And the last one, 1 is greater than negative 1, so we get 1, 3. So 0, 2, and 1, 3. Notice those 2 and the open circle all use x plus 2, so I can connect those on a line, and that is my other function. Now, some other questions you might encounter are the ones like evaluate using this function. So if we want to evaluate f of 3, I need to ask, all right, where does f of 3 work? Well, 3 is greater than 1. That means I'm going to use this part of the function, and I'm going to use the x plus 2 part. So we get 3 plus 2, which is 5. And if you notice over here, the point 3, 5 is right there on the function. Ooh, 3, 5. So you can evaluate it using either the function notation or the graph or even the table, if that was a point on our table. Let's evaluate f of negative 1. Negative 1 less than or equal to negative 1. So 3 times negative 1. We're going to use the one that's or equal to, and we get 2 as our function. We could also tell that from the table here, and we could tell because when you evaluate at negative 1, not the open circle, but the closed circle is the one that's included. Last one here. 3 is greater than 1, so we're going to again use the bottom function. And when we do that, we get, oh sorry, not 3. 12 is what's greater than negative 1. 3 is also greater than negative 1, but we get 14 as the output. Thank you very much for watching.